The idea behind series is that a lot of times we want to know, does the series converge or does it diverge? So we're asking, does the sum approach some sort of number or does it not? So what we want to look at first is called the term test. The nice part about series is that if the terms of the series don't go to zero, then the series automatically diverges. So I'm calling this the term test. And basically, if you're starting with a series, so here's your series, and this is really important. If the limit as k approaches infinity of these terms does not equal 0, then the series diverges. And you always want to check this first, because if the terms aren't going to 0, then you don't have to do any other test. You can just say, the terms don't go to 0, so the series diverges. It's not true that if the terms go to 0, then it automatically converges. This is just a test to rule out which series converge and which series diverge by looking at the terms. So a couple of examples. Let's first look at the sum from k equals 1 to infinity of just 5. So does this series converge? Does this series diverge? Well, the limit of the terms, so limit of 5 is just 5. That's not 0. So this series automatically diverges. Let's look at two more. What about the series from k equals 1 to infinity of k plus 1? So again, I'm going to look at what happens as k goes to infinity of just the terms of the series. Well, this is infinity, definitely not 0. So this series diverges. We'll do one more. How about the series from k equals 1 to infinity of negative 1 to the k? Well, the limit of negative 1 to the k, that's just going from negative 1 to positive 1, negative 1 to positive 1, negative 1 to positive 1. So this limit does not exist. Well, that's not 0, so this diverges. You're only going to use this to prove that a series diverges. You're not going to use it to prove that a series converges. But if you can show that it diverges immediately, do that. Otherwise, you have to use some other test.